Hi everybody. So we're going to start chapter 3, which is all about quadratic equations, okay, so x squared type of equations, and we're going to start by talking about 3.1, which is extraction of roots. Okay, so extraction of roots is a method of solving quadratic equations. Okay, this method is also sometimes called using square roots. Okay. Okay, so here's our steps to completing this method. So the first thing we want to do is isolate the square. Okay. Then we are going to square root both sides. Okay. The third thing we're going to do is finish solving if necessary. Okay. All right. So let's do an example of using this method. Okay. Okay. Now you should have seen simple examples of this in your Algebra 1 class, but we're going to do some more complicated examples. Okay, so we're going to solve using square roots, or this might say solve using extraction of roots. Okay. Both of those directions would be referring to this same problem. Okay, so the first thing we're going to look at is this equation. Okay, so the first thing we want to do is isolate this x squared, right? That's our square in this equation, so we're going to try to isolate x squared. Okay, so in order to do that, the first thing I'm going to do is multiply both sides by 4. Okay, now I'm going to add 8 to each side. Okay, and then I'm going to divide both sides by 3. Okay, let me make sure I have divided that correctly. Yep, okay. All right, so now that I have my square isolated, I'm going to take the square root of both sides. Okay, and I'm not going to forget that when I take the square root of both sides of an equation, I need to include plus or minus. Okay. All right, so the square root of x squared is x. Okay, square root of 16 is 4. So I'm going to get two answers, 4 and negative 4. Okay. All right, let's look at another example like this. Okay. So the first thing we're going to do is subtract 15 from both sides. Okay, and then we're going to divide both sides by 9. Okay, and as is always the case in this class, we're just going to leave things as a fraction here. Okay, so now I'm going to take the square root of both sides, and I'm not going to forget about my plus or minus. Okay, so square root of x squared is x. Okay, now I'm going to split this up into root negative 14 over root 9, okay? And then we're going to simplify these separately. Okay, so remember we saw in the last section that when you have the square root of a negative number, that's really a complex number, okay? So this is going to be root 14i, okay? And square root of 9 is 3. Okay, so in the previous example, we got 2 real number solutions. In this example, you can see that we've gotten 2 complex solutions. Okay, all right. Let's solve a couple more, maybe one more equation like this, and then we'll look at a different type of equation. Okay, so the first thing we're going to do here is combine all of our like terms together. Okay, so I'm going to add x squared to both sides. So 1x squared minus 1/4 x squared is 3/4 x squared. Okay, and then I'm going to subtract 17 from both sides. Okay, so I'm just going to do 43 minus 17, and I will get 26. Okay, all right. So now I want to get rid of this 4, so I'm going to multiply both sides by 4. And I get 104. Okay, and then I'm going to divide both sides by 3. Okay, now this doesn't come out evenly, okay, so I'm just going to leave my answer just like this. Okay, so now I need to take the square root of both sides. Okay, so right now we're looking at, okay, our equation currently, all right, is x squared equals 104 over 3. Okay, so what we're going to do is take the square root of both sides. Okay, and we are going to, here, we'll get that the square root of this is x. Okay. And then over here, we're again just going to split this up. Okay, and try to see if we can simplify this at all. Okay, you should remember simplifying these a little bit from your Algebra 1 class. Okay, so this is 4 times 26. In fact, that's how we got that number. Okay, and we know that the square root of 4 is 2. Okay, so the part that you can't take the square root of, which is 26 and 3, stays inside the radical. Okay, and we took the square root of 4 to get this 2. Okay, so there's our 2 answers, and again, we have 2 real numbers. Okay, let's look at a different kind of equation that we can solve using this method. Okay. Okay, so the first thing we're going to do here is isolate our square, okay? But now we can see that our square is this whole thing here, okay? So I'm going to divide both sides by 16. Okay, but I'm going to leave this all together because this is all part of the square here, okay? So now I'm going to take the square root of both sides. Okay. Now x plus or minus, or the square root of this expression squared is just going to be x plus 1/2. Okay, and then over here, When I take the square root of 1 over 16, I get 1 over 4. Okay, so the last thing I need to do is subtract 1/2 from both sides. Okay, so I want to remember what this means. Okay, this means I have two different answers. Okay, so my answers here are that I have x equals negative 1/2 plus 1 over 4. Okay, that's one of my answers. And the other one is that I have x equals negative 1/2 minus 1 over 4. Okay, so these are my two solutions, and I'm just going to simplify them. Okay, so negative 1/2 plus 1/4 is negative 1/4. Okay, and negative 1/2 minus 1/4 is negative 3/4. Okay, so there's going to be my two answers, negative 1/4, negative 3/4. Okay, so I will get two whole number answers, but they're not opposites of each other like the previous example. Okay, let's do one more example like this. Okay, so I'm going to try to isolate my square, which is here. Okay, and the first thing I'll do is divide by 2 on both sides. Okay, so 38 divided by 2. Okay, and that gives me 19. Okay, now I'm going to take the square root of both sides. And I'm not forgetting my plus or minus. Okay, now I have the square root of a square, so I'm just going to get the argument, which is 5x plus 3. Okay, and over here I can't really simplify this because the square root of 19 doesn't come out evenly. Okay, so now the next thing I need to do is subtract 3 from both sides. Okay, but you can't subtract 3 from root 19 because they're not like terms. So I'm going to have something like this. Okay, and then I want to divide both sides by 5. Okay, now I can't divide root 19 by 5 because they're not like terms. Okay, so I could write this as negative 3 over 5 and 19 over 5, or I could write it like this. Okay, so you have two choices. Write it as one big expression, or split it up like this. Okay, both of these mean the same thing, and either of them would give you your two solutions. Okay. All right, so we're going to continue to practice with this, but we're going to look at an applied example. Okay. All right. So this says, what size rectangle can be inscribed in a circle of radius 30 if the length should be twice the width? Okay. Now when it's describing the length and width, we know they must be talking about the rectangle because a circle doesn't have length and width. Okay. So the first thing I'm going to do is label my picture. Okay, so the length is going to be twice the width, so that means this long side is going to be the length. Okay, and the shorter side over here is going to be the width. All right, now I'm going to label the radius of the circle, which goes from the center to the outside here. Okay, and I know that that's 30. Okay, all right, so what I know here, right, is one thing that I'm being told is the length is twice the width. Okay, so the length is twice or 2 times the width. Okay, so that's a piece of information that's coming right from the question. Okay. Now, the only other piece of information I have, really, is this picture. Okay. Now what I want to do here, okay, is try to think of some geometric way to relate these three things. Okay, I do have three pieces of information and I just want to relate them using some fact about geometry. Okay, so if I was you, I would pause the video now and try to relate these things. Okay. All right. So I'll tell you what I would do. Okay. I would look at this triangle here, okay, that I know is a right triangle. Okay, so I'm going to draw that triangle right here. Okay, so I know that this side, which is the hypotenuse, is 30. Okay, this side, if you look, is going to be exactly half the length of the rectangle. So this is going to be W over 2. Okay, and this part is going to be half the length. So this will be L over 2. Okay, and I'm going to relate these using the Pythagorean Theorem. Okay, so W over 2 squared plus L over 2 squared equals 30 squared. Okay, so that's coming from this right triangle using the Pythagorean Theorem. So I'm going to rewrite this. Okay, so 30 squared is 900. Okay, and like we've talked about in class before, if you have fractions like this, you can always multiply it by the LCD. Okay. All right. Okay. So here's our two equations. Okay. And we really want to solve this. Okay. This is a nice quadratic type equation where we have a square, and we think we might be able to use the square root to solve this just like we have in the other problems. Now the issue with that is that we really don't know how to do that when we have two variables. Okay. So I'm going to use a method from chapter 2, okay, and I'm going to substitute for L this expression 2W. Okay, so in here, where I would normally have L, okay, I'm going to plug in 2W from this equation. Okay, so now 2W squared is 4W squared. Okay, and now I can combine my like terms. Okay, I want to isolate my square, so I'm going to divide both sides by 5. Okay, 3600 divided by 5 is 720. Okay, and now I'm going to take the square root of both sides. Okay, so let's just double check that that doesn't come out evenly. I don't think it does, but we'll just check. Nope. Okay. Now, the only thing about this that's super important, okay, is that I need to pick which one of these makes more sense. Okay, and because this is a width of something, it makes more sense to pick the positive one. Okay, so again, you're choosing the positive root because you're describing the length of a side. Okay, now if we wanted to find out the length here, okay, we know that the length is twice the width. Okay, so we would have that the length is 2 times root 720. Okay, and I would be happy with your answer just in that very format. Okay, let's look at another type of example. okay? An example type that we're going to come up with a lot in this class, and we're introducing it now, is compound interest, okay? So when you're talking about compound interest, principal is the initial investment or loan, and that's a dollar amount, okay? R stands for the interest rate, which is a percent written as a decimal. A stands for amount, so that's the final amount of in your account, and this is the dollar amount also. N is the number of times the account is compounded per year, and T is the time in years. Okay, so here's the compound interest formula with those things that we just talked about. Initial investment, interest rate written as a decimal, number of times compounded per year, number of times compounded per year, and time in years. Okay. All right, let's see an example of this. All right, Cyril invests $5,000 in a money market account for 2 years. The interest is compounded annually. Okay, so when you see that the interest is compounded annually, okay, this means that N is equal to 1. This interest is compounded 1 time per year. Okay, that's what they mean by compounded annually. Okay, so we're going to write an equation for the amount of money in his account A as a function of his interest rate R. Okay, so we're going to look at what we had on the previous page. Okay, and the first thing we're going to do is change this into function notation by making A the name of the function, okay, and R is our input variable, and remember we know that because it says as a function of R, okay, so that tells us that our input variable is R and our output variable is A, okay, and then I'm going to fill in as much of this stuff as I can from the question, okay. So in the question it says he initially invests $5,000, so I'm going to put that here. Okay. His interest rate isn't given, and in fact it says his interest rate is our input variable, so we're going to leave R. Okay. It said compounded annually, so N is 1. We'll have N as 1 up here too. Okay, and in the question it said he invested for 2 years, so that means that T is 2. Okay, so I'm just going to simplify this just a tiny bit. So I have 5,000, 1 plus R, okay, I don't need R over 1, and then here this is going to be squared. Okay, so this is why we're looking at this example right now. You can see that this is a quadratic type equation where you have a square. Okay, all right, so we're going to complete this table. Okay, so you guys know how to fill in a table, so I would pause the video now and complete this table. Okay, so they're giving us values for R. We're going to plug them into our equation, okay, and then we're just going to so if for 0.02, for example, we'd have 1.02 squared times 5,000, okay, so here we're going to get 5,202, okay, 5,408, 5,618, 5,832. Okay. All right. So that's just giving you values for R. You plug it into your equation and find A of R. Okay. All right, let's look at part C. Okay. If his goal is to have $6,250 at the end of the 2 years, what interest rate would he need to have? Okay, so let's copy our equation. Okay, now it's saying that his goal is this dollar amount. Okay, so we really only have 2 choices. We can either plug that in here for A of R, or we can plug it in for R. Okay, so because it's a dollar amount, and because it says what interest rate, meaning this is the variable, Okay, we know that we need to plug this in for a of r. Okay. Okay. So first we're solving for r. So this is when we're going to use our extractions of root method. So we're going to isolate the square by dividing both sides by 5,000. Okay. Okay. Now we're going to take the square root of both sides. Okay. So over here we have the square root of a square, so we know this is going to be 1 plus r. Okay, and over here I'm just going to leave this for now. It doesn't come out evenly, like it doesn't come out nice and even like a whole number, so I'm just going to leave this for a second. Okay, and now I'm going to subtract 1 from both sides. Okay, all right. Again, I'm going to choose the positive value because your interest rate is a positive percentage, right? They're not taking money away from your investment. Okay, so we're going to choose the positive value. Okay, and I'm going to go ahead and get the estimated value from my calculator. Okay, so when I plug this into my calculator, I get something that rounds to 0.118. Okay, so remember r is the interest rate as a decimal. Okay, so if r is 0.118, okay, we would say that he needs an interest rate of 11.8%. Okay, you're changing it from decimal form 0.118 back to percentage form 11.8%. Okay, all right, so that's a quick reminder of how to do extraction of roots, and then a little example of how you might use this with some word problems. I will see you guys soon.